It's already been switched, my dear. So
Oh
now I
my
get to
gosh,
say,
Leon.
don't worry. Oh, welcome to another wonderful instance of Streaming School. We are very fortunate today to be joined by Mr. Sam Winch. I've already taken 1 or 2 minutes of his time, so I'm going to get off screen as quickly as possible. And Sam, the floor, as they say, is yours, buddy.
Brilliant. Cheers, Leon. So welcome back again to another session of Mathematics GCSE, where today we're looking at surface area. On Wednesday, of course, we worked through volume. We didn't get to the final one, which was frustums, and that was a word that was new to some people. So we're going to be looking at frustums to start off with. But yeah, Nish, if you can share my screen, please.
Cool.
So we've got, we're going to start off by recapping the volume. So we've got the formulas here on the right-hand side of our 3D polygons. We've got your prism, which is volume equals base times height. So obviously work out the base. You've got the trapezium on the left-hand side. Sorry, the trapezium-based prism. So obviously work out the area of the trapezium and then multiply that by the height or the length, which is 10 centimeters there. Then we went through cylinders, which is pi r squared times height. Then we looked at cones, pi r squared divided by 3, and then multiplied it by the height. And then we've got the pyramids, which is length times width times height divided by 3, and then we looked at spheres as well. And we quickly looked at hemisphere, which of course, instead of 4/3 of pi r cubed, is 2/3 of pi r cubed. So a quick recap there of what we did on Wednesday's session. And quickly, as I did promise, we'll look at the volume of the frustum, which is grade 7 to grade 9. So it's the top end of your higher paper. Here you've got a cone on the screen, and I'm going to share my screen with you, and we're going to see if we can work out the volume of this frustum together. Now remember, a frustum is simply a cone or perhaps a pyramid with its top chopped off, if you like. So all we're going to do is work out the volume actually of the cone to start off with. Okay, so remember the volume of the cone is going to be radius squared times height, and we're going to then divide that by 3. Okay, so if we quickly go with 10 squared to give us 100, and if we times that by 50, which is the height, to give us 5,000, and then if I can use my trusty calculator to then divide 5,000 by 3 to give me 1,666.6 reoccurring. Okay, so I've now got the area, I've now got the volume of the cone here. But of course, we're not working out the volume of the full cone, we're working out just the shaded area. So we need to subtract the top half. Okay, now how do we work out the top half? Well, if we know that in the ratio of the cone was height 50 and radius 10, and we also know that the height of the area cut off at the top here is 20, and we say that the radius is x. So of course, we don't know what the radius of this part of the cone is, so the top part, we don't know that radius. But actually, if we use ratio, we can work out, well, here we've divided by 5 to get to 10, so 50 divided by 5 equals 10. And again, if we just do the same method here, that will give us x. So 20 divided by 5, of course, gives us 4. So x equals 4, okay? Or the radius equals 4. So now I've got the radius, and again, we're going to use r squared times h times height and divide it by 3, okay? And this will give us the top part of the frustum, okay? The top part of the cone. So we know that r squared was 4, so we go 4 squared is 16, and 16 times 20 would give us the top part. Of course, 16 times 20 is 320, and 320 then we're going to divide it by 3, okay? And again, I'll just use my trusty calculator, which gives us, of course, 106.6 reoccurring. So to work out the full volume of that frustum, we're going to subtract the the shaded area, the actual frustum itself, and subtract from that the top part of the cone that's being chopped off, if you like. So if we can go 1,666.6 recurring, and we subtract from that 106.6, then we'll get the answer of 1,560 centimeters squared. Okay, so that is how to work out frustum. If you're confident with your cones, then it's simply find the top part of the cone or pyramid and subtract it from the bottom half. Okay, and that is a grade 7 to grade 9 question. Okay, so if I can come back to my screen, that clears up volume. As you can see on my screen now, we're going to work today on surface area. We're looking at the polygons of a prism, a cylinder, a cone, a pyramid, a sphere, a cube, and a cuboid. So we're going to try and tick off as many of them, if not all of them, if possible. Okay. So first of all, what is surface area? And I've found this diagram that I think actually plays a key part in describing what surface area is. Excuse me. And at the bottom of the page, it says, well, surface area is the area of a surface. So if you just swap these words around, you get a definition, if you like, of what surface area is. It's the area of a surface. So once you work out the area of one side, then work out the area of all the sides and then add them together. Now, I'm going to give you a few formulas that will help speed up the process, if you like, working out what the surface areas are of shapes. Oh, fucking throat today. But if you look at this first one, in fact, if we go back to that question, what we could say here is, what is the difference between these two shapes and what is the same? So we know that the difference would be on the right-hand side, you've got the volume would be greater, but the surface area of both would be very similar, okay? Obviously, the surface area of the top layer and the bottom layer would be the exact same, okay? The sides would be, of course, greater as well, but we're going to move on to that shortly. Now, first of all, to recap the properties of our 3D shapes. We spoke about the faces of each shape, and of course, you've got the vertices, which is the corners of each shape, and then you've got the edges, which is where our shapes join together. Okay, so we've got some 8 examples here. We spoke about the tetrahedron as well. If we get time today, we'll try and cover the tetrahedron. Okay, but to start off with, we're going to look at a cube, and that has 6 faces. Okay, 6 faces. So that's what we're going to look at to start off with. As you can see in this example, we've got 17 inches is the length of one side. And the formula here is, well, first of all, let's just find the area of one face. And we know the area of a face of the cube is base times height.
Sorry.
So therefore, here we've got 17 squared, which of course 17 squared would give us 289. Then if you multiply 289, you will get 6. Okay, and that's why we've got the answer here, 1,734. So if I can just share my screen with you here, I'm going to zoom in on the cube in particular. Just wait for that to zoom in. Brilliant. So here, very similar. Again, you've got 13. I'm going to use my trusty calculator to my side. We've got 13 up the side. To find the area of one face, of course, we're just going to do 13 squared, which gives us 169. Okay. Now we know that there's 6 sides to this cube. So if I just multiply that by 6, nice and easy, I get 1,014. And this one is done in feet. 1,014 feet squared. Okay, so that's area of the cube. Now we're looking at a cuboid. So again, we've got 6 faces of the cuboid, as you can see here, 12 edges and 8 vertices. And what we're looking at doing again is finding the surface area. So 2 sides are the same at either end of the cuboid, and then you've got the 4 rectangular sides that we need to work out. So there's a couple of ways we can do this. What we're going to do is work out the length times by the width of either side of the cuboid, and then multiply the length and width by 2, and the length and the height by 2, and then the width and the height by 2. It might be that you or 4 rectangulars, depending on the size of the shape, depending on the size of the cuboid. It might be that you're able to multiply it by 4, okay? But here we are going to break it down. So here you've got 20 times 4, which would give you the top and the bottom. 20 times 6 would give you the 2 sides. And then from the left and right, you've got 6 times 4. Now, if we add them all together, you get 448. And I'm going to give you an example of how to work out cuboid. If I can share my screen now, brilliant. Okay, so first we're going to look at this face and its opposite face, which would be 13 times 3, which would give us 2 lots of 39. Now we're going to look at 9 and 3, which would give me 2 lots of 27. And then if we're looking at the face, the top and bottom of the cuboid, we're going to be looking at 13 across and 9. So 9 times 13, 117. So we've got 2 lots of 117. And of course, if I look at adding them all up, just realised, sorry, there's the working out there. If I look at adding them all up, I've got 2 times 39, which of course gives me 78. And then I've got 2 lots of 27, which gives me 54, and 2 lots of 117, which gives me 234. Added all together, we've got 16, 12, 15, 16, and 3 there. Okay, so the total surface area for that cuboid would be 366 inches squared. Okay, now we're going to move on to our next shape. We're looking at triangular prisms. So very much like our cuboid, if you will, find out the base first of the triangular prism, and then you can move on from there. There's a couple of ways again of doing it. Here's a description of how to find the surface area, which is 2 lots of the base plus the perimeter times by the height. But what I'm going to do today is work out the base of the bottom of the triangular prism and add that to all 5 faces. Okay, so here we've got 324 inches squared would be the total of this one. And you've got 15 times 6, which give you the top layer. Of course, 12 times 9 divided by 2 would give you the base layer, and you can multiply that by 2 to get either side. So if I can share my screen again, and we've got an example here of a triangular prism for you. So the first thing to remember is the area of the triangle, which will give me that the top end and the bottom end of the triangular prism. 6 times 4, 24, divided by 2 would give me 12, which is the area now of this face. Of course, if I multiply 12 by 2, that would give me the 2 end faces. And then the other 3 faces would be 11 times 5. Of course, that's a rectangle. So 3 times 3 lots of 5 times 11, which gives me 55. And if I finish that sum up, 2 times 12 is 24. 3 times 55 is 165. And add that together gives me 189. And here we have 189 yards squared. Okay, so now we're going to move on to our 4th surface area 3D shape, and we're looking at a cylinder. Here, similar to volume, where we find out the area first of the cylinder, and then of course you just multiply it by the height. Okay, here same thing, but you're just going to do it twice. So here we do pi r squared. 7 squared is 49, multiplied by 3.14, and then multiply that by 2. Once you've done that, if you do the same thing but include the height, okay, that'll give you 791.28. Let me give you an example on my screen. So you've got the surface area here. The radius is 10. and the height is 16. So here the first step would be to 10 squared to give us 100, and then multiply that by pi, which of course, if we're using 3.14, that would give us 314. It's a very active house this morning. Apologies if that's coming across. Then we're going to multiply that by 2 to give me 628. Okay, now all I've got to do is add to that the pi r, or pi times radius times the height again, 2 lots of that, and that will give me the surface area. So there's the area of the top circle and the bottom circle. Now if I do radius, which of course is 10 times by the height, which is 160, and then times that by pi, and if I choose my trusty calculator, that'll give me 502.4. So if I can add 628 to 502.4, but of course before I do that, I must multiply by that by 2 to give us 1004.8. So if I add those two sums together, that would give me a grand total of 628.0, which give me 8.2361. 1,632.8, and sorry, I've gone into a bit of space here, but that'll be yards squared as well. Okay, it's quite a bit of working out there in terms of the surface area of a cylinder. As you can see, find out the area of both ends of the cylinder first, and then just add that to the height times pi and the radius times 2, multiply by 2. So cylinder of a surface area. Now we're going to move on to the surface area of a cone. Now remember, we've done surface area of, we've done volume actually, sorry, already this morning of a cone. So hopefully that will allow you to remember how to do the volume of a cone, and it links nicely to the surface area of a cone. So pi r squared, and then you're going to add to that pi, radius, and s. S is for slanted side. Sometimes you're given the vertical height, sometimes you're just given the slanted height. So depending on the question that they're asking for, if it's volume, they might give you, they're more than likely going to give you the vertical height, sorry. If it's surface area, they will give you the slanted height. So just be aware that you're likely to be given both or just one. Okay, so here again, you've got 2 is the radius, 2 squared, of course, is 4, multiplied by that by 3.14. That will be your first part of the answer, and you get 1 mark in your exams just for doing that first part working out. And then you're just going to add to that pi 3.14 times the radius, which is 2, times the slanted height. Okay, and that'll give you 56.52. So again, if I can give you another example here on my screen, we've got the radius as 9 and the slanted height as 11, and I've just realised you've got about a minute left, so I'm just going to do this one last example for you. We've got 9 and 11, and if we can go pi r squared, so 9 squared is 81, multiplied by 3.14, which gives us 254. 254.34, and then finally we're just going to do pi 3.14 times the radius, which in this instance is 9, and then we're going to multiply that also by 11, okay, to give us 310.86. And finally, we've just got to add all that together, and you get the grand total of 565.20 feet squared, and that is the surface area of a cone. And Nish, if you can share my screen, please.